too late.
Okay, here we go. I'm going to carry you guys with me. Can you guys stop talking because we wasted enough time? Nope. Zip. Okay, here we go. Well, maybe I'm not carrying you. Hopefully you can hear me from there. Okay, so we're going to go into more detail about the 4 spheres that we learned about yesterday, okay? So we learned yesterday, and I'm just going to kind of skim through some of this, 4 major systems: the geosphere, biosphere, hydrosphere, and atmosphere. Each system is a collection of parts that works together. I'm going to take this off for a second. Yesterday, Zeke was asking questions about, well, what about corn after it's not on the stalk anymore? And what about an animal after it dies and it's not alive anymore? And what about this globe? And what about this marker? Which sphere are they a part of? So when we're talking about the 4 spheres, we're talking about things that were naturally created. We're not talking about
Human-made objects.
things that no longer exist or human-made objects. So like when you cook your dinner, that's a human-made thing. It's no longer part of a sphere. It's not living, so it's not part of the biosphere. It's not something else that occurs naturally in nature, like the air and the wind,
Like
or rocks or whatever. Tacos are not part of a biosphere. They're not part of anything. Okay? The floor, the carpet, that's not part of anything that was man-made. Okay? So does that kind of make sense? So when we're talking about the 4 spheres, we're talking about things that are created naturally without us doing anything.
What about like that, like your desk? Isn't it metal? Because isn't there metal?
Now, some of the things that we make come from one of the spheres, but the desk, my desk itself is not in the geosphere. It is made from different elements that can be found in the geosphere, different minerals and metals, and maybe even some wood. I don't know what it's made of. So those things were a part of either the biosphere at one point or the geosphere. Most of our furniture was either made of wood or a metal of some kind. So it was either a part of the geosphere because metals and minerals and rocks, that was geosphere. If it's made from wood, that was originally a tree, that was part of the biosphere. So like furniture comes from one of the 4 spheres, but at the point that we start messing with it, it's no longer part of the spheres. Does that make sense?
Yeah.
Okay. So I wanted to kind of clarify. Zeke asked me that yesterday. I didn't want to give you guys the wrong answer. And I'm like, well, that is a really good question because like my dining room table is all wooden, but it's not part of the biosphere. It's not a tree anymore, a living tree. Okay.
But it's wood.
It's wood, but it's no longer part of the biosphere because it's not a living creature.
I have a question. Dead animals aren't man-made or anything, so are they geosphere?
So a dead animal, once it decomposes, goes into, it could turn into a different part of.
Oh yeah, like worm.
And we will talk about some of the interactions as we get deeper into this. But for example, right now, let me think here. So, okay, an animal dies. I don't know, something in the forest. A deer dies. Okay, thank you. I was like, something that could die and live naturally. Okay, so a deer dies in the woods. It's laying there dead. Some animals are going to come eat off of it probably, right? So some of it becomes like nutrients for another animal. But what they're probably not going to eat is its bones, right? So its bones are going to be laying there. And those bones are eventually going to start decomposing and or go down into the soil, right? They're just like weather and natural things, like leaves are going to fall on top of it. Things are going to start decomposing. We learned about decomposing already, right? And so it's going to start disintegrating, or it's going to go down into the soil. It's going to become a part of the soil, at which point then eventually, if you think about like millions of years, we've got like dinosaurs, right? And those bones could become fossilized. It's a whole process that we'll learn about later. But if those bones were to become fossilized, then they become a part of the geosphere, because then they're like they're in the earth and in with the layers of rock and mineral, right? Okay. But
in the soil, are they?
if some of those, if part of like maybe part of its muscles or skin is in there and decomposes and goes back in the soil, then the worms and the other things are eating it and using it as nutrients. So it's getting recycled. Okay. So it's not technically still part of the biosphere. It still stays within the biosphere if the other animals are eating it, because then it's going back into another living creature. Right. So here we're going deep. Matter, which is everything we see, can touch, can feel, is neither created nor destroyed. It just can change form, but a matter stays the same. Ooh, just fun, deep science stuff. Okay, but that's like D&B and maybe even high school level science. But yeah, nothing ever actually goes away. It just changes form. Get excited. Maggie.
That's creepy.
Creepy.
What would even like humans' dead bodies would be part? Would it be part of something or not?
What a human's dead body. So we get buried usually in coffins. So we're not going to we decompose, but we're not becoming a part of the earth and fossilizing.
Yeah,
Okay.
we're not like
So
that.
no. Okay. So let's look at this. So each system has parts that work together. So like yesterday, we learned that a lot of the biosphere and geosphere work together because the grass has to grow in the ground. Like the plants that are part of the biosphere have to have the geosphere to survive, right? And clouds, we had to talk about, well, are they hydrosphere because they're made of water, or are they atmosphere because they're in the sky? So some of them are really closely related, and there are pieces that relate all of the different spheres together that depend on each other. So we have to have all four. Lily, yeah.
I'm sorry for interrupting, but Josie just raised her hand.
Oh, okay. Sorry, I didn't hear it. The sound isn't as loud because I'm just on Lily's Chromebook. Josie, yes, ma'am.
Thanks. So I want to know, do we have so I see a bunch of the words that are highlighted. Are there going to be any of those? Like, do we have to write them down?
No, no. Good question though, Joes. Okay. This might be easier if I sit near you guys instead of jumping around. Lily. Yes. Sophie.
When we were talking about like decomposing, it reminded me of whenever me and my family were walking in our creek, we found 2 bones and we realized that reminds me that of our dead turkeys that died like 2 years ago.
Oh wow.
So I have the big bone.
All right. So Sophie was telling us that she when we talk about decomposing, she remembers walking around in her yard or the creek bed and finding some bones there that were just kind of laying there from something that had died a few years back. Okay, we need to move on because we lost a lot of time early in the session for no reason. Sorry, not that I don't want to hear, but I love you. Okay, so if certain parts of one of these systems gets damaged or missing, it may not work it out as well. It may affect other systems. So think about this. If it rained and it flooded, would the plants be able to grow? Right? So one system can negatively impact another. Or if it didn't rain for a long, long time and we had what's called a drought, same thing. The geosphere, the ground, is going to get really dried out. That doesn't necessarily hurt the geosphere, but the biosphere is going to start to suffer, right?
Yeah, and that can cause like fires and stuff if the ground's really dry.
And if the ground is really dry, then it can also lead to like fires. If there's wind, dry, windy conditions are like when you start seeing like the forest fires and stuff spreading. That's what happens like in California when you see all of that. Last year in Australia was like on fire for like a large portion of last year.
It was terrible.
Yeah. Okay. So let's, good Lord. I might have to sit over here. Psych. All right. The fun never ends today in science. All right.
It's already ended though.
Okay. So Earth is the only planet that has the 4 systems. 7 of the planets do have an atmosphere, which is a layer of gases that surround the planet, but only Earth has the biosphere, which is all of the living stuff, right? So we know we're the only planet with life. We knew that already. Okay. The only planet in our solar system. Jason, yes.
Remember that mystery dog we had once when at the end it was talking about how scientists were discovering that there might be
life on another planet?
There is not intelligent life on any planet in our solar system. Now, think about this. We learned that every star we see in the sky is its own sun in its own little universe. So think about all the millions of universes that are out there. Is it possible that one of those has a planet with a Goldilocks zone? Probably, but they're so stinking far away. We can't get there to discover them, and they can't get to us.
Aliens.
Okay, but again, guys, let's stay on Earth. Let's focus back in. We're on Earth. We're talking about Earth today. All right. So we have these 4 spheres, and we're the only one that has a biosphere. Okay. 7 of them have an atmosphere with gases that surround the planet. And some of them have a geosphere, because we know that some of them have like actual like ground on them. If I think about Mars, we know that they have like red rocky soil. But we know that Jupiter is made entirely of gases. So does Jupiter have a geosphere? No. Do what? Do some planets have water? Yes, some do. No, wait. It's mostly gases, and some of them have rocky, but the further out they get, they all turn to gas planets. I think we have found evidence that there maybe once was water on the moon and Mars. If you get too close to the sun, why is there no water? Too hot. It's too hot, it would evaporate it, right? And you get too far away and it would be frozen. It would be ice. It would still be water, but it'd be ice. But so at that point, if the water is in the air in its gas form, then it's really a part of the atmosphere. It's in its gas form. So gases around the planet are atmosphere. So actual like running water, like liquid water, only on Earth that I know of, but I feel like I read that there was evidence that maybe there was once water on Mars. Moon isn't a planet, so we can't talk about it. Okay, so geosphere and biosphere. Earth's biosphere includes the living things in the air, water, and on land. There is a mountain lion in the photo, but I don't know if I scanned that. Here he is. He's one of the millions of living things that's part of the biosphere. Now, we have living things because we interact with the other spheres. Could we live if we didn't have the atmosphere?
No.
Why not?
Because we would float off in space.
No oxygen. No, it has nothing to do with floating off into space. No oxygen. Why do we need oxygen?
To breathe.
To breathe. Okay.
And tons of asteroids would hit Earth because they wouldn't burn up in the atmosphere.
Okay. And then Zeke said Earth would be destroyed because asteroids get burned up in our atmosphere as they enter. And if we didn't have the atmosphere to burn up those asteroids, we'd just be constantly bombarded and we would be destroyed. Didn't think about that, but you are correct, my friend. Without the atmosphere, Kaylee says we wouldn't have any water. Explain why the atmosphere helps us with the water. Josie.
Because all of the water, like, it's a cycle. Like, we learned about the water cycle a long time ago. Everything's a cycle, and then we need everything because it rains and then it just like evolves.
Right. Could we live without the geosphere? We wouldn't have, if we were just, we wouldn't have ground, right? We would just, then we would be a gas planet and there would be no surface for us to stand on, to build on, to live on, for things to grow on. So we wouldn't have the plants or animals. Okay. All right. So it's pretty easy to see that we need all 4 systems interacting together. Zeke.
There could be water on other planets because there is undiscovered planets in our solar system. There's like millions of planet X's that we can't get to.
Okay. Zeke was talking more about space. I'm going to keep moving on with Earth. Okay. It says the large rock in the photo that this lion is jumping off of is part of the geosphere, which is the rocks, soil, and sediment. Sediment is like all the teeny, teeny, teeny little particles like sand or like the grains and dust of dirt that you see sometimes. Like sometimes you pick up a rock or a dirt and then you just have like a kind of like a dust on your hand from it. That would be kind of like the sediment is like the teensy, teensy little particles. Rocks are easy to see. But rocks are also below the surface. Some of the rocks are molten, which means melted. And rocks are present in all parts of Earth from the surface all the way down to the very center. If we were to somehow drill all the way down, the geosphere goes all the way to the core. And so it's everything underneath us all the way through. Sam.
So I don't think that this would be good for the Earth. But if it was, we could do it. Like when all the trash piles up, you could drill all the way down to the center and just throw it all in that hole. Then the center would burn it, right? Couldn't it?
But people have
Sam wants to drill to the core of the earth and put the trash from the landfills in there so that it just burns up.
But then you're risking your life just to burn trash and then.
So kind of similar to going deep down in the ocean, you go deep down in the earth and the pressure's going to be so strong. Like I think you would get crushed.
No, not like you. Just get a long, like.
But even the pressure might crush like the metal.
Yeah.
Like pressure gets so strong at
How
certain.
does that pressure get strong down there if there's a hole above you with air? And there's not water. There's something
Because it's wanting to fill, because that's in the grand scheme of like all of Earth pushing and it's going to want to fill that space. Like if I were to have something that's packed really tightly together, the Earth is packed really tightly, and I drill a hole, it's going to naturally just shift. Like when you dig a hole in the ground, the dirt just naturally the loose dirt wants to keep falling and filling it back in. So it's going to want to fill that space. And there's so much pressure because you dug so deep that I think it would crush whatever it's working on.
The oceans are if they're deeper than if you put Mount Everest in the ocean, it would take like 2 more.
Yeah. Okay. So now we know geosphere goes all the way deep. Let's keep moving. Nope, that's the wrong one. Hang on.
I wanted to look at that.
You're going to look at this one first. Okay, so this is just a quick little overview of geosphere and biosphere together. So it shows you that there are different layers as we go from our Earth's surface. You see the continents over here. So the crust, that is the part that we live on. Okay. And then you go, and it says it goes 100 kilometers deep. That's about as far as you could reasonably dig, and you would still need specialized equipment. 100 kilometers, kilometers are larger than miles. So that's more than 100 miles. That means like you'd be digging the equivalent of driving for 2 hours straight into the earth, that far down. Okay. So that's a lot. Mantle is the layer below that. So on our picture, the yellow layer, and it is another 2,866 kilometers even further deep. Then you get to the outer core, which is the orange in the picture. And it's liquid.
That's when you're gonna crush.
Okay. And yeah, so the outer core is made of a liquid. It is, so that's like all the molten rocks, kind of like if you think of like lava would be the thing that you guys would recognize, right? And that's another 2,260 kilometers deep. And then you've got the inner core, the red part, and it is a solid, and it is circumference 1,220 kilometers from one side to get to the other side of the core. Okay. So that's the geosphere. Again, we'll talk more about that in detail, but on the crust, we're also talking about like all of the things on the crust. So not just dirt and sand, but we're also talking about, like we talked about in the video yesterday, the mountains, hills, rocks, boulders, canyons, any landform like that, plateaus, any of those landforms that you've heard about in previous years. That's all part of the geosphere. Okay.
Makes up about 84% of the Earth's total volume. That's a lot.
It is a lot. Okay. Biosphere, we know, and we have talked about the biosphere a lot. We've been studying this entire past quarter, second quarter. We talked about plants and animals and decomposing and that whole life cycle. So I think that you guys, and plus we are the biosphere, us. So we know a little something about our biosphere. We are on the crust part of the geosphere. Okay. All right. Let me go back.
Miss Bab,
Yes.
I have a question.
Yeah.
So, I have got these out. So these are it's a souvenir from Yellowstone, and they're like not in the geosphere, are they? Because
they were a part of the geosphere at one time.
It's like colorful and because it's definitely like man-made.
No, well, so here's the deal with that. They were originally part of the geosphere, meaning that they were down in the crust. They were one of the layers of rock, like they were probably some sort of special rock or mineral. And when like people dug them up, like, so this is where the man-made part comes in. So what you have, those stones were originally part of the geosphere. They were buried down in the crust somewhere, not as deep as the mantle, but they were somewhere in the crust, and men harvested them, or women, people dug them up, and then they they broke them into small little pieces, and they polished them up and made them smooth and pretty so that they could be souvenirs for you. So now they're no longer a part of the geosphere, but they were once a actual part of the geosphere. Have you guys seen those? Landon has some of those at home too, like those kind of shined up pretty rocks of all different colors and whatever. Landon got his at Eckert's. When we were at Eckert's one time, they have a display of them in their store. And I had some when I was a kid that I got at the Science Center here in town. Josie, hang on. Let me go back to you. It put me on the screen, and I don't want to be on the screen. Does it have me pinned to your screen, guys?
Yeah, you just have to throw the rocks with the iron in them.
No.
Okay. Josie, hold up one of your rocks again so my kids can see. I don't have you on the big TV. All right, guys, this is what Josie was talking about. Like one of those.
Oh, those, yeah.
I got one from Texas.
You know what I'm talking about? Like those. Keep holding it up because I've got to walk around the room. Yeah. Those kind of, like those polished colored stones. I don't have my mask on. I'm dying. Okay.
Wait, can I see Miss Bob?
Oh, you didn't see? Okay, hang on.
I have wait, can I bring mine to school tomorrow?
Possibly. Okay. Thank you, Josie. Oh, my Lord. All right, hang on one more time. Zeke didn't see.
Oh, yeah, I have. Along with one.
Okay. All right, we got to keep moving. Next page. Lithosphere. What? There's another sphere? Can't be. Okay. Lithosphere. An important part of the geosphere is the lithosphere. Sometimes you actually hear the geosphere referred to as the lithosphere because the lithosphere is the part of the geosphere that we interact with. It's the part that we can actually go out there and touch. Okay, it's part of the crust, right? So the lithosphere is made up of the outer rocky parts of Earth and includes the crust and the outer rigid part of the mantle. Below the lithosphere, the solid rock of the mantle can move and flow. The lithosphere is not only the outer layer of land, it also forms the bottom of the ocean. The lithosphere can be much thicker below a continent than below the ocean. The lithosphere can extend more than 200 kilometers below continents. So if you think about that, it's called sea level. So if I were to go stand on the beach right now, I'm standing right here on the beach, right? And the ocean starts right here. And the ocean gradually gets deeper and deeper and deeper and deeper, right? So think about this, though. That means if I'm just standing right here, there's solid ground underneath me. But if I were to be over here out in the ocean, it's just water. So that's what they're saying is underneath the ground that we stand on, the actual continents and the countries and the cities and the towns, the crust goes deeper than it does in the ocean, because as the ocean gets deeper, so if I were to, now I'm at the bottom of the ocean, I can't really be at the bottom of the ocean, but if I were, the crust might only be this thick, because that's as deep as it goes. But then when the crust is over, now I'm in the mantle. Okay. So the bottom of the ocean basically is kind of at the farthest depth of the crust. Does that make sense? So then as the ocean gets more shallow, the crust is getting thicker on land. Okay. So that's how that works.
There's a faster way down to the
So, and it shows that in the picture. Okay. So here's the picture that we have that shows, here's where we are on the beach, and this is how thick it is, and here's the crust. But we've got this part here. So here's the mantle, this light gray or light brown. Okay. All right. That's page 108. Now we're going to go to this one. Now we're looking at, we kind of started talking about the ocean. We got the hydrosphere. All of the water on, under, or above Earth's surface makes up the hydrosphere. Most water on Earth is salt water, and only a very small amount of it is fresh water. Most living things need the fresh water to survive. Just if we were to drink salt water, it would eventually make us sick. Our bodies can't process that amount of salt. Okay. It would eventually be toxic to us. But there are some things that live in the ocean that obviously need the salt water, and they would die if you put them in a regular freshwater pond. But most, think about the size of the Earth, and the oceans are all salt water. So most of the water on Earth is ocean water, is salt water. So it's just a very small amount that actually is the fresh water that we can actually use. Now, and again, we talked about the reason that, and so when they say in the earth, the water that is in the earth, so we have like, we know that if you dig deep enough, you could hit like a water line. Have you guys ever dug deep enough that the ground started getting wet?
Yes. Yes.
So there's water under the surface because I think it rains and then that water absorbs into the ground. Like it has to go somewhere. So there's like some water down in the earth. And then we've got the water that's on the surface. So our ponds, our lakes, our rivers, that's technically considered on the surface of the earth. Okay. But once it starts evaporating, then it's turning into its gas form. And then when it's a gas, then it's a part of the atmosphere. Good. Okay. Zeke.
So we have this weathering creek in our backyard, and so like when it rains, it fills up and flows, but when it doesn't, it's dry. And then we look for arrowheads in there, and once we were digging in it, and then the ground got like really wet. And then close by there's springs. What are the springs from? Like it comes from deep down in the earth.
Okay, so Zeke is asking about a natural spring that happens. Some of you might have vacationed or been to a place that has like springs or geysers. Geysers are like things that like where water just explodes out of the earth. And so yeah, that's from water that, like little pockets of water that are down in the earth. And the pressure that's down deep makes it want to rise. If you think about it, if you go deep enough in the earth, is the temperature getting warmer or colder?
Warmer.
It's getting warmer as you go down towards the crust. So it's getting warmer down there. It's heating that water up. And if you think about when water bubbles, it starts to kind of want to rise. Heat rises.
Spring water freezing cold. And spring water, it's so clean because it goes through the rocks and minerals. Well, there are hot springs, but usually it's
Okay. So there's hot springs, there's cool springs, but again, it's the pressure that's inside the earth, I believe, that's pushing the water to the surface. And it's just like a natural area where it's open down to that like water level that's under the earth. Okay. And geysers, I think, are kind of like the same as volcano, but just they go into a water pocket instead of all the way down deep into the molten. Right. Okay. All right. Next. Oh, so looking at this picture over above the mountain on the right-hand side of the picture, it shows ice and snow. Are they, because in this picture, they're up in the sky, the ice and the snow. So are they atmosphere or are they hydrosphere? Ooh, I heard both. Let me go to a person virtual. Fiona, ice and snow that's in the sky, but it's actually falling from the cloud. So it's not in the cloud anymore. It's falling like it is in that picture. Is it hydrosphere or atmosphere?
I'm gonna go with hydrosphere
Why?
because it's not in the cloud no more. Now, if it was still in the cloud, it would probably be atmosphere, but it's out of the cloud, and now it's going to head to the ground. And then once it touches the ground, then it would definitely be hydrosphere.
Yes. As it's falling, it's hydrosphere because it is actual water in one of its forms. It might be frozen water. Ice and snow would be frozen versions of water, but it's still water on its own. It's not in its gas form anymore. So does that make sense? In the cloud, it's still in gas form, but once it actually, like, remember we talked about, if you're in my room, like the water molecules are hanging out, and then I think I had some of you come up and we all like bundled together and we were too heavy and we had to rain. And so when the water droplets and the water gases all collect together and they're heavy enough to fall, then they become actually part of the hydrosphere. Zeke.
I have a question about that. So if the water,
You're a weird dog.
water like snow, because you can
Don't call my dog weird.
Look at him. He's standing on
Yeah.
his back.
Somebody needs to mute.
and then it steams, and then you can freeze it, and it's frozen like ice, and you can have it liquid. And then how do you get it like snow? Because snow is like a solid.
It's so weird because my son asked me the same question on the way home randomly yesterday. He's like, what's the, like, he's like, so if rain is just like room temperature water, and he's like, but then it's like below 32, it should turn to ice because it's freezing. So he's like, where's snow and sleet? And like, what determines if it's sleet or rain or hail? Because hail is like a really firm ice. Sleet is like kind of like a mushy ice, and snow. So what determines? I don't know, but I will research because Landon asked me this yesterday too. Random science questions all the time. Okay, I got 5 minutes. We got to move, friends. Atmosphere. Layer of mixed gases that surrounds Earth. The most plentiful gases are nitrogen and oxygen. Thank goodness for us. Other gases such as argon, carbon dioxide, and water vapor are also in the atmosphere. So we knew water vapor was up there. That's what we're just talking about. Like it hangs out in the clouds. And we know carbon dioxide's in our atmosphere because we know that's what we exhale and breathe out, and the plants breathe it in. But in this diagram, it shows that the atmosphere is absorbing the sun's UV rays. So these are the things that are harmful to living things. UV stands for ultraviolet. Our bodies cannot process direct ultraviolet light. It is a type of light that we cannot handle. If you have a sunburn, it is because you were exposed to too much UV lights. Okay. So we do get UV rays, but if you're not spending time outside for a large portion of time without sunscreen, then you're normally fine. But that is why we need to wear sunscreen, because those rays are hotter and they can burn us, right? Okay. So without our atmosphere, all of these UV rays would be coming straight to Earth, and it would make us hotter. Not only us, it would heat the Earth more, and we would not be able to sustain life. We would eventually just burn up. Yes. So hang on just a second. Atmosphere allows visible sunlight to pass through that helps warm our surface just enough for us to live and mostly be happy, right? Right now, it's a little cold out there. We just came in from recess. We're about to go again. It's chilly today, but it's still warm enough that we can live. UV rays, we can't see them. They are not something they're invisible to our eyes. You need special like science machinery and things to be able to detect UV light, but our bodies can sense it. So even though we can't see it, we still can, our bodies feel it. Okay. So that's where it would be harmful to us. And then the atmosphere traps some of the heat that leaves our surface to keep us warm enough year round. So if, and it says suppose, and I like this question down here, if the atmosphere was only half as thick as it is now, what might happen to Earth, and especially to us in the biosphere? Parker.
Maybe it would get too hot.
Parker says it would probably maybe get too hot. Who agrees with Parker? Probably get too hot. Okay. Jason has a question.
Okay. So how do trees give us oxygen if they're also actually taking the oxygen?
Trees aren't taking the oxygen. Trees bring in carbon dioxide and they give out oxygen. We do the opposite. We bring in oxygen and give out carbon dioxide. So we need each other for breathing. We're going to learn more about that next week, because it talks about how two of the spheres interact together. When we breathe and the plants breathe, what two spheres are interacting?
Bio and
Atmosphere and biosphere. Good. So we're going to talk about that next week. Hang on. I think there was one more page that I needed to show you. Let me see if I can find it.
Is that hurricane page?
This one. Okay. So it says hydrosphere and atmosphere together. They constantly interact. For example, rain and snow are common in many parts of the world. The temperature of the air affects the kind of precipitation that will fall. So that's a really watered down answer to Zeke's question about what determines if it's sleet, snow, ice, hail, rain. But I don't know which temperatures are which, so I'll have to research that. Another example of hydrosphere and atmosphere working together is a hurricane. Hurricanes are large, swirling tropical storms. You guys have heard of hurricanes before. I think we talked about them when we learned weather in 3rd grade.
My grandma lived through a hurricane. She had to go out of Florida, I'm pretty sure.
I was gonna say, yeah, because your grandparents live in Florida, so they are used to having to be around dealing with hurricanes, I imagine, all the time. All right, they bring damaging winds and lots of rain, and they form when a lot of water vapor enters the air due to evaporation of warm ocean water. And so it's the difference between really warm ocean water and a really cool atmosphere, and that causes the swirling to start and the hurricane. The speed and pattern of the winds distinguish or make a difference between just a regular storm and a hurricane. Okay. Whoa, lots of questions from my friends out here. Sean. Yeah. Lily.
When I was in Gulf Shores this summer, like a week after we left, there was a hurricane.
Lily said she went to Gulf Shores, which is Alabama on the coast, and she said there was a hurricane right after they left and came home. Zekel.
Okay, so I have one question. I have two questions. One of them is, why do hurricanes travel instead of just swirl in one place?
Zeke asked why hurricanes travel instead of staying in one place, because there are things called air currents. And so as the air currents move and the temperature of the air moves, it kind of pulls the hurricane with it, I think.
Okay. Now my second question is, if there's no water on Jupiter, how does it swirl and why does it stay in one place? And does it rain at all if there's no water?
He's also now asking about the Jupiter, and Jupiter has that big eye that we have been told is a big storm that's been going on for years and years and years. And he said, if it's a storm, how can it be a storm if there's no water on Jupiter? When you say storm, you're assuming that it's a hurricane type storm.
Is it a rock storm?
It could be like a dust cloud type storm. It could be, I don't know much about it.
It's an electrical storm.
It's an electrical storm.
Would the gas move it though? It doesn't move it.
It doesn't really move. I don't know. I don't know the answer to that, Zekel. I'll have to do some research for you. Okay, Josie question.
Well, mine isn't about science, so.
Okay, Grace question.
Well, it's not a question, but we went to Dolphin Island during the summer, and when we came back, there was a hurricane there, like how I forgot who said, but how somebody said when they left.
Mm-hmm.
that happened the same with us.
It was probably the same hurricane. You guys were probably down in that area the same time. Very cool. Not cool. I'm glad you guys got home in time and you were safe.
Yeah, we did too. We got it.
Yeah, we
It was
went
like-
to Gulf.
Yeah.
Yeah.
It was like the final 3 days. It was just like bad weather.
Apparently Sam and Parker were down there too. So a bunch of you were not afraid of COVID and went to Florida this summer. I'm
It
jealous.
was last summer.
Oh, Sam says this was last summer. Wouldn't be traveling during COVID. But some of y'all were like,
last summer.
COVID, whatever, going to Florida. Dude, I am jealous of y'all. Okay.
Well, actually,
Lily's world traveling. She doesn't
we
care.
had to wear face masks and the face shields.
Wait, what?
We wore face masks and face shields.
Wow, you like doubled up. Awesome, Deej. You were staying super safe. Yeah, because you were down there for a whole month at the beginning of the year, right?
Yeah, I was down there here taking like summer vacation because like a kind of like Russian summer vacation because we couldn't
Right.
do it because of COVID at first. So
Right.
we had to do it a bit later in the year.
That's smart. Because when you guys went was kind of when it was kind of calmer. Late summer before school started and right at the beginning of summer wasn't so bad. Okay. Done with science for today. I will see you guys in an hour for writing.
Miss
Bye.
Fab.
Yeah.
So are we going to? You can stop recording. I wanted to know if we were going to